After doing the video the other day showing the clamp meter at the electrical panel, showing the load of different things, I had a viewer saying, yeah, but I can't use them on a regular cord. Of course you can't. You have to separate the neutral from the hot. So I'm going to teach you guys how to make yourself a real simple little cheater cord so you can use your clamp meter to measure individual appliances. It's real simple and it costs basically nothing to do. You can do this for about $2. Let's check it out. You know, normally I wouldn't touch this, because you know what they say about touching shit, right? They tell you don't touch the poop. You see a steaming pile of dog crap sitting on the ground, you don't touch it. Unless it's your dog, then you got to pick it up, but that's why I don't have a dog. They tell you not to respond to trolls, and I've been ignoring this twit now for, I don't know, 7 or 8 years. But John, it's getting kind of repetitive, you know? Johnny Senchek, that's who I'm talking to. John, I know you're watching. I know you're craving the attention, so you're going to get the first couple minutes here all the attention that you want. What is your problem? I thought maybe 7 or 8 years ago you were a 10-year-old that was just kind of being childish, but it's been 7 or 8 years now, so you got to be 17 or 18 now, right? You're still acting like you're 10. What is your problem, man? You know, do I really need to get 50 or so of these Google network operations complaints coming from your email? Do I have to get this every time I post a video? It's not just me. You're also harassing FranLab. You're harassing the EEV blog as well as others. I've talked to them. We've all talked about you. We all have some fun things to say about you that I won't repeat on the channel. But I think that I have to address the elephant in the room, and the elephant in the room is you. Okay, listen. Your complaints to Google go absolutely nowhere, right? None of us are violating anything on Google. None of us. Let's take a look at your message here. Where was it? Well, just take a look at this one here. You're saying, you're sending a message to the Google NOC, or the Network Operations Center, saying that my videos are misinformation, copyrighted video music, shadow ban. Okay? This is what you're saying. So you send this message off, you create a ticket at Google, which incidentally, I've spoken to Google. It goes absolutely nowhere. They're just sending me a copy to let me know that you've filed a complaint. But you are on their ban list, like you are on my ban list. You can't post on my channel because you were misbehaving 7 or 8 years ago. You found yourself banned. Well, you're banned from Google, but whenever you file one of these complaints, they have to forward it on. But it goes nowhere. I've already spoken to YouTube about this. They're fully aware of you. They figure you're a nutcase like the rest of us. But let's just take a look. Oh, you're sending it to 33 recipients. Let's take a look at some of your FloridaMetadata.com. That's your website, isn't it? Where are the rest of these ones here? So you're sending this out to everyone. Compliance at YouTube, admin at YouTube. You're sending out to all these. Administration. Oh, you sent a copy of it to Fran Blanche. Great. Yeah, she needs to read your complaint about me to YouTube. That's okay. I get complaints you send about her as well, including when you posted her address and her phone numbers and stuff. I'm sure you've tried that with me too, but you see, the phone numbers you think are mine are not, because they've been changed. So keep it up. Some poor guy that you mistakenly took down what you thought was my cell number and spammed him. He contacted me because you spoofed my old home number that you got out of the phone book before I changed my number. You spoofed my number so it showed up on his phone, and he phoned me up asking me what my problem was, and I told him that the reason he's getting calls is because a crackpot in the States thinks he's phoning my cell number, but he was off by 1 digit, so he's got yours by mistake. So my bad. I get the same thing here. Let's take a look at this thing here, and let's just see what we got on here. I figured I would give everyone your email address, since you like to throw everyone else out there. Support at admin.andyhotmail.com. That's John Senchek. So, you know, it's like, so you've got your 5 seconds of fame. Now here's something that I have to tell you. I did speak to a fellow that I know who's a lawyer, and I am in a legal right position where I can sue you for criminal harassment. If I wanted to, I can. Because this is considered criminal harassment, what you are doing. Now, I know if I was an American, I'd be taking that up right now, and I'd have you in front of the judge right so bloody fast it would make your head spin. But us in Canada, we're a little more level-headed. We don't do that. We're just asking you, grow up, stop it. You know, it doesn't benefit you, it doesn't benefit me, it doesn't benefit Google. I just have to delete all these messages, and I've got them actually set so that they automatically delete, so I don't even see them. They show up in my inbox, and I just click delete, and they all get deleted at once. But I shouldn't have to delete 100 or more messages from you a day. And even this, you know, you contact my ISP. What are you trying to do? What do you think you're going to accomplish? I have done absolutely nothing that violates any of YouTube's terms of service. There's been no copyright. Any music that I play, I have a license from the artist to play that music. It's royalty free and it's all licensed. There's nothing that I do that violates any type of copyright. The only one here with a problem is you. It's time for you to grow up, John. Act your age. I know you're more than 10. Act your age. So this one I'm going to do a little demo on my little clamp meter and how we can use this to measure current. Of course, everyone knows that, well, I mean, the NCV will tell you if you've got power flowing through a cable, but you can't measure current flowing through a cable like that, because the current clamp has to go around only one conductor. It's not going to measure anything because the current flowing out on the hot side is returning on the neutral, which will cancel it out. How this works is it creates a transformer and it has to go around one single conductor. Now, if you're working in your electrical panel, that's one thing, because you can clip onto the individual hot wires or the individual neutral and measure the current going out versus the current returning. But how do you do it when you've got a regular cord like this? Well, there's an easy way. You make yourself an adapter. So I went down to the dollar store and I picked up one of these little short, they come in different lengths. This is a little 1-footer, and it's just a 3-prong connector, you know, to give you that extra foot when that power cord is 1 foot too short to reach to the outlet. You can get one of these. They come in different lengths. I've even got I think I got a 3-footer kicking around here somewhere. Yeah, I do have a 3-footer here. Right, this is a 3-footer that I've also got, which I use on my workbench just to extend the power for when I need it. So this is another one here, right? I mean, these are readily available. You can buy them. This one might even be easier because it's got the 3 conductors here. You just have to open it up to get to the one of them. It doesn't matter whether you do the hot or the neutral. Either one is going to do the same thing. But I figured I would show you on this little demonstration cord, which I picked this up at the dollar store. I think I paid $2.25 for it. It was cheap. Anyway, I've been using this for a set of Christmas lights, so I guess I'll have to get another one for next year. I got a set of Christmas lights which are just a little bit too short to reach to the outlet, and rather than have a big 6-foot cord coiled up there, this fit the bill. So I happen to have one kicking around. I figured I would use this one to do this demonstration. So what we're going to do is we're going to open up a section of this cord so that I can get to the 3 separate conductors. There should be a green, a white, and a black. And it doesn't matter, I can either use the white or the black. The green should show nothing. It better show nothing. If the green line is showing current, then you've got a ground fault. Right, but let's open this cable up. So I'm just going to use my good old snips and just nip a bit of the way here, just so I can get in. And I'm going to open up maybe 4 inches of it. Give myself lots of room to work. So I just got to carefully, I don't want to nick the conductors because that would create a hazardous situation. So I'm just very carefully just cutting a very, very thin. Now if I can get, I got the green conductor here, which is the ground one. If I can get these under here and then use them just to open the cable up. And then if I do damage one, it'll just be the green one. I'm just going to open this cable up. Now one can do this with a knife too, it's just that I happen to have some really sharp electrician's snips handy, so this is what I use. I just use some pliers to walk this back. Open the cable up, get another pair of pliers here to grab it. And I should be able to just zip open several inches of the casing. Just like that. I think that's probably more than enough. That is definitely more than enough, because we just need to be able to get a loop on the wire. So now I can just cut this off. Okay, so now we've got our three conductors, our neutral, our hot, and our ground. If I take my fan that I tried to measure before and I plug, this is another extension that I made up, plug that in like that, and plug my fan into this end and turn it on. Get my fan going to full speed. I can now take my current meter and just clip it onto either the black or the white, and we'll see that this fan is drawing 0.36 amps on the black wire. And of course we should see the same amount of current returning on the white wire, because what goes out on the hot has to return on the neutral, and of course we should not see anything on the ground wire. Now if you were to do around the ground wire and the hot wire at the same time, you're still going to see it, because the ground wire is not carrying any current. So you can check either the hot side or the neutral side, you'll see the same amount of current flowing through both. Now that we've covered that, I'm now going to compare this and see how accurate it is. I'm going to plug my kilowatt meter in. I've got to kick it around here somewhere. We'll look at what it shows, and I'm also going to throw a regular ammeter on from a regular meter, and we'll see how different they are in accuracy between the two. I think they probably should be pretty close. I don't know that these type are quite as accurate as, say, a dedicated current meter, just because of the diameter of the transformer core that's made here. One in a meter works, like one inside a DVM works the same. It has a current sensing loop with a current sensing magnetic field pickup below it, but it's a calibrated distance, whereas this here, you're just inserting a wire through the loop, and it may not be quite as accurate, but it should be. We'll find out when we get set up with the other equipment. Here I've got my little kilowatt meter in, set to amperage mode, and you can see it's 0.38 amps. And this one's measuring 0.36 at this particular moment. It did say 0.38 a second ago, but there we go, 0.37. So we're pretty close. We're pretty close between the two of them. This one might be a little more accurate just because it's calibrated, and this one here is just a wire floating free within the transformer, but they're still, you know, we're talking milliamps different. You know, 0.36, 0.37 versus 0.38. The next test, of course, is going to involve a meter. This one's got current capabilities on it, so let's just get the meter set up. We'll put it into current mode, whichever one that is. AC, there we go, AC, hertz, telling me to plug into, look at this meter lights up for me, telling me to use the common and the 10 amp range. So I'll plug one into the 10 amp range, and I'll plug the other one into the common. Now how are we going to hook this up, you wonder? Well, this is actually a lot simpler than you would think. See, I'm just going to take out the plug, and I'm going to put the neutral side in and just stick it like that. So the neutral side is plugged in. Now the hot side's open, and as is the hot side here. And then I'm just going to take my meter, and I'm going to stick one side into this. Got to pull those off, expose those conductors a little more. I'm going to stick one side into here. This is for my ground. And the other side I'm going to stick into the hot side, like that. Now, I'm not on my isolation transformer now. This is plugged in directly, so if I were to touch this, I would get a nasty shock, but I'm not making a connection. Oh, because my probe fell over here. Let's secure this a bit. I decided to put it on the hot side because that way I can stick the neutral one into the ground side and show that the fan will still run, returning on the ground conductor, so we can actually get some current flowing through this. Okay, let me turn the fan back on. And, where's my AC? I'm on DC function. AC. There we go, okay. Now here's an interesting one because this is registering a little bit higher. This meter is registering 400 milliamps, 0.4 amps. This one's registering 0.36, and this one is measuring 0.38. So they're all in the same ballpark, but they're measuring slightly different, and it's due to the way that they measure. And I would say that this one is probably the most accurate because this is a certified meter. It's calibrated. It is an actual test instrument. So I would give the actual meter measuring the current flowing through the circuit, through the meter, I would give this one the most accurate rating over these other ones, which are just using, these both use a similar technology. This one is just using a coil that's on the hot side to measure the current going through a shunt. As is this. This is measuring the current going through a wire, but it's not, there's no actual physical connection. This is doing a similar thing, but this is a calibrated meter. So I would give the calibrated meter the higher marks for accuracy as to what is going on. Now remember I said I can measure on either the hot or on the neutral side, right? And I'll get the same reading here, except for I'm not getting the same reading this time. Why am I not? Oh, because I had it going through both. Well, that'll do it every time. Okay, 0.35. Watch this. If I loop it through here and this one, I was getting I should get 0 actually. That's measuring through this wire here, going to the meter. I'm still getting the same reading, which I would expect. Now, if I move this over to the ground wire, of course, I'm not going to see anything. And I see 0. So I saw 0.04 there for a second, but it may have been just some residual readings. If I take my ground out and I put it over on, or take my neutral out and I put it over onto the ground, obviously that is going to work. But I'm going to try something else. I'm going to go and grab my GFI protected outlet and we'll watch the GFI trip. Let me go grab that. I'm now plugged into a GFCI plug. Got my little extension cord plugged in there. I've still got my fan plugged in. I'm on the neutral side. As you can see, just in standby, the fan actually draws 0.06. That's just because it's got circuitry on it that, switch the mode on this here. 118.8 volts on this outlet. Is that amps? Okay, let's turn it on. Power factor, that's power factor is 1, by the way. You can read it. Power factor is 1. .48 watts, 40 watts, 41 watts. 0.39. This one's measuring 0.4. And this one's on the ground loop, which is measuring nothing now. When I move this over to the ground, this should immediately trip. Even without turning it on, because there should be enough residual leakage through this unit just from the power supply that it should sense it returning on the other than through neutral. It should sense it returning to ground, and it should trip as soon as I put this in, which it does. See that? That's how they work. If I reset, now remember, when the fan is off, it is drawing 0.06, so 66 milliamps roughly. The GFI will trip at, I think it's 25 is what they trip at, so that 66 milliamp draw going to ground trips the GFI. Plug back into the regular outlet though, with a proper ground, with no GFI, that fan will run. And that's why GFI outlets are so important. If that current is passing to anything other than the neutral, in other words, if you've got a piece of equipment in a fault condition, if the current is passing through you, for example, to ground, the GFI will trip immediately. Every bit of current that leaves on the conductor, the hot side, has to return on the neutral. That is what a GFI plug does. It monitors the balance between the hot and the neutral. The neutral must equal the same amount of current that's going out the hot. All electronics work that way. Anything that goes out the hot has to return on the neutral. If it returns anywhere else other than the neutral, it trips it. So by plugging the fan into the ground receptacle, I've got nothing flowing through the neutral. You can see I've got my 0.35 amps going through the ground side, and there's nothing, of course my fan turned off there, there's nothing going through the neutral. So that's the prime for a GFI trip. Got current leaving on the hot and nothing returning on the neutral, because it was returning, in this case it was returning on the ground wire, but it didn't have to. I could touch that and ground it through my body. I'd feel a little bit of a jolt and momentarily until our GFI plug opened, but it wouldn't kill me. That's how GFIs work. Anyway, I just wanted to do a little quick video here, and I know bashing the troll is probably not the smartest thing to do because I'm just feeding them, but this has been going on now for so many years. I think that everyone needs to be made aware of these idiots that are out there. I mean, we all know they exist, and we all wish that they would just, I don't know, get struck by lightning or get hit by a bus. Anyway, I figured I would just make this little video that's probably gone on too long now to show you guys how to make yourself a little cord so that you can use your clamp meter to measure individual appliance consumption. Thanks for watching. We'll catch you in the next one. Bye.